So for this one, lots of good questions about how do I make this work, right? So I put these two together just because I think it's important to see this, right? Because again, I've really emphasized this. As we talk about carboxylic acids, they're acids first and foremost. They're acids, right? Yes, so unlike other carbonyls, where we always kind of go to the carbon of the carbonyl group, with carboxylic acids, we need to remember that it's an acid, right? And so both of these cases highlight that. This one's a little easier to see because we obviously can tell this is hydroxide, O-. It's much easier to see. Yeah, of course, we're going to do a deprotonation, and then we're going to make a hydroxide. Or carboxylate. We made water, and then this carboxylate, right? We can actually use the carbon of the oxygen of the carboxylic acid does an SN2 reaction, and in this case, I drew it where there's a stereocenter. So we had a good question about, well, what would it do if it's an SN2 reaction with this? Would it invert stereochemistry? Absolutely. Right. So the final product here would be H there, oxygen. Right. We do an SN2 reaction. This is a way to form an ester. Right. This is a way to form an ester in basic conditions. So this forms an ester in basic conditions. Right. So what did we just form? We just formed an ester in basic conditions. So the first step was a deprotonation. Then we did an SN2 with an alkyl halide to make an ester. I want to compare that to this one up here where you have an amine around. You have an amine and a carboxylic acid. What actually happens here, what's going to happen first, all right, so there's my ester and base. The amine is going to deprotonate, right? Because an amine is a good base. Amines are good bases, right? Nitrogen has a lone pair. It's not that electronegative. It's going to be willing to deprotonate this. And you're going to get something that looks like this, right? This amine salt. Right? Now, what can happen, and I'm not worried about the mechanism here, if you have enough heat around, enough energy, right, you can overcome this and actually make this nitrogen react there. Right? You can overcome this and eventually get to this. But it's going to take a lot of energy, right? It's going to be difficult to do, right? Because once you form an amide, that's a pretty strong bond there, that nitrogen-carbon bond. But it's going to take some heat, some pressure. You are generating water. Folks want to know where the water came from, right? Well, there's the H, there's the O, and there's the other H, right? That's where the water came from. So a lot of times, right, these are, of course, equilibrium reactions. You can use Le Chatelier's principle. If you remove the water, if you remove one of the products, that'll help drive the reaction towards completion. So you could boil off the water. If you have over 100 degrees, you could boil off the water, right? It becomes a gas and it's gone. You can use drying agents. You can use molecular sieves, they're called, that soak up the water and help drive this reaction towards completion. But by itself, at room temp, it's just going to deprotonate and you get something like this. You're going to need a lot of energy and maybe some Le Chatelier's principle to help you make this go. So another way to make esters from acids, so we have the basic conditions, deprotonation, SN2. We have acidic conditions, protonation, series of additions, proton transfers, get to the ester, and generate water. And then we have this other way with diazomethane, which is really kind of a basic condition type thing, actually, because you have a C-. So the first step here is going to be a deprotonation. Right, deprot. That's going to give you an carboxylate. And now you have a CH3, which of course has a really good leaving group. N2 is a good leaving group. Nitrogen, the plus charge, also is going to generate a gas. So then we can do just an SN2. And this is a good way to make methyl esters, right? You just made a methyl ester. Just added one carbon there, and then you also made N2. So this is the diazomethane. Diazo meaning N2, methane being 1 carbon. And it's really very similar to the basic conditions to make esters.